Hello everyone, this is Solvents Florinor with Wilkers and Raymond, and on this is my presentation on the object counter. So the object counter is implemented on an Arduino, and its purpose is to detect different signals. So we have two sensors, and one sensor would be reading signals or object going into a place, and the other sensor will be reading signals going outside of the place. And I I'm gonna be using this project as a tracking system to monitor how many people goes in and out of my house. That's actually why I decided to work on this project. Um, I actually made a demonstration on YouTube that actually talks about everything. So I'm not to save time. I'm actually gonna run through a couple of things, but mostly everything is covered in the demonstration. So requirements. So of course the user has to put the system in a place where the sensors can properly read the signals. For example, me, I use my system at my door because that's where everyone has to go through the door. So whenever someone goes inside of my house, the first sensor gets activated and it increments the number on the 7 segment display. That's how many people it's actually inside of the room. So the second requirement is that the system has to be able to detect, object going in and out of the room. And whenever an object go in, then the counter has to be incremented by one and decrements when an object exits. There's actually different sensors that takes care of that. And then the number of people, of object or people that's inside the room is actually outputted on the 7 segment. And let's just do the second part of the requirements, which is that, of course, that makes sense. There can't be negative numbers on the 7 segment. So whenever there's nobody in the room and someone exited, then the system should never decrement past zero. Because if the system was placed at the door, but there were already people inside of the room, when those people walk out, then the system should still be at zero. And of course, if the system is at 9, since I'm using 1 7 segment display, then it should just go back to 1. In the video, I made a mistake and I said that it should go back to 0, but the demonstration is clearly going to show that it's 1. It's my fault for saying 0. I actually programmed it to go back to 1 since I used 1 of them. So I went over the architecture in detail in the demonstrations, but I'm quickly gonna run over it over here. So we have an Arduino, we have sensors connected to it, and we have the 7 segment display. So the sensors are read by the Arduino pins, and then the signals is sent out to the 7 segment display, depending on whether the first sensor gets activated or the second sensor gets activated. And this is the use case diagram. I'm just going to leave it here. Take a look at it. I'm trying not to go over my time limit here, but it's pretty simple. I'm just going to go over the sequence diagram. The system has to be placed in an ideal location. It has to detect the object going in, and then if it increments by 1, it would decrement depending on whether the object is going in or out. And then the system should not increment past 9, should not decrement past 0. Very simple stuff. We actually use C++ to because that's how we can program the Arduino. The sensors we use are the FC51 sensors, and these sensors are heat sensors, so they work by determining heat. So whenever uh, they sense heat in a certain distance, then the sensor would actually get activated, and that's how it can read the objects going in and out of the room. And of course, a 7 segment display is used to actually show how many people or object is actually entered the room. Not actually entered the room, but how many um, objects is actually in the room for that exact moment. And this is the timeline. Of course, we have everything done because it's the end of the semester and we actually finished the project. And this is everything that we had to do right there. And this is the project environment. We use GitHub to work together. It's actually a great tool because we I would work on something and I'll just save it and he'll just pick it up right there. And because we worked on everything together, we each didn't have our our own part to do. We just kind of went along and help each other out within everything of the project. So we work together on everything. And now we're gonna go over the. This is the demonstration. Please go to this YouTube link to look at it because I'm using a tool, and whenever I try to play the video within the tool, then there's some bugs and issues. So please go to this link to actually kind of like a second part of the presentation to where I actually go over everything slightly a little bit over again and actually break down the whole project and actually test the project and see and show off what the system does. Thank you so much. I hope everyone had a great semester. Dr. Agarel, Professor, thank you for a great semester. As always, I liked it. The class was very formative, very project based, and I'm very happy to have taken you this semester. Thank you.